I'm Nasli Mensah. This is group 9, and we'll be taking the input and output in computer architecture. Input simply refers to the data or instruction given to the computer to work with. The input stage is a very important stage in the input process output. That is the IPU. The process is what the computer does with the input, and the output is the result of the process. That is the information the computer produces after processing the input. Please move to the next slide for me. IPO cycle in computer systems: input, process, output. The input is the data or instruction you give to the computer. The process: this is where the computer works on the input to make sense of it or transform it. Processing is done by the CPU, that's the central processing unit. Output: this is the results the computer gives back after processing the inputs. Thank you.
So I'm Roxanne, and I'll be tackling inputs. When we talk of input is the act of feeding data or instruction into the computer from the outside world. We can also say it's any data or signal sent into the computer for processing, and it is a crucial part of the IPO, which stands for the input process output. So the following are the things we can input into the computer system, and they include raw data from users, sensor signal, network packets, file or multimedia data. Component involved in input. The first one is the input device, which helps us to feed the computer with data, and they include the keyboard, mouse, scanner, microphone, and the sensors. The second is the input unit, which is a part of the system that converts the input into binary or delivers it to the CPU, which is the central processing unit, or the memory. This is the function or how the input unit works. So it converts data into a format the computer understands, that is in binary. The second is it accepts data from the outside world. 3, it transfers data to the main memory or the CPU registers for processing. We have the input devices, the hardware input devices. We all know of them, but I'll still touch on it. We have the camera, which helps us to take pictures, and as we can see here, it says it helps in image or video inputs. The second is the sensor. The third is the keyboard. The fourth is the mouse or the touchpad. The fifth is the scanner, and the sixth is microphone. Thank you.
Vale. In this May 1 of Kale, I'm taking from the inputs in instruction cycle. And then in the context of the instruction cycle, the input involves fetching data from input-output device using control signals. So I want to explain on that. So in using the control signals, the CPU controls the key, from the input devices, that's the keyboard and the storage. And in the input-output instructions, we have the special CPU instructions like the in, read, or load, which are used to interact with input devices. And also we have the memory mapped input-output, which treats systems devices as if they were memory locations. And input devices are assigned specific memory addresses, and reading from them are retrieved data. An example is reading from the address which fetch the keyboard inputs. Can I get the next slide? And here we have the types of inputs in computer architecture. And then we have the program inputs, which instructs entered into to be like instructs information to be executed. And we have the data inputs that takes raw data that needs to be processed. And then we have the control inputs that signals users or their devices that affect operations. And we have the interrupts that signals from hardware to get the CPU's attention. Can I get the next slide? So we have the input-output controllers. So the role of this is they act as intermediaries between input devices. An example is the keyboard and the sensor. And the function is they manage low-level communication, that's the voltage signals and the time. And the second one, I have the interrupt handling. And this role of this is they determine which input device has data ready and alerts the CPU. And the function is input device trigger hardware interrupts to signal data availability. In the last one, I have the direct memory access. And this rule is they transfer large info, example, from a disk or a camera directly to the RAM without a CPU's intervention. And the function is they bypass the CPU to reduce workload and speed up transfers. Yeah, can I get the next one? And also I have how computers handle inputs. So the process of handling inputs in a computer involves several key steps to ensure. But what we know is, firstly, the input unit receives data. That is, they collect raw data from an input device such as keyboard, mouse, sensor. And then the example, when you press a keyboard, an electric signal is generated. And in the second one, we have the signal translation into binary. That's the zeros and the ones. That's it. It actually changes the what you type into the computer's language for it to understand. And we have the storage or the CPU processing. That's the binary data that is stored temporarily in the memory. That's the RAM. And later sent to the CPU for immediate processing. That fetch, decode, and execute the cycle. And an example of this is a scan document that's saved in the memory before being displayed or edited. Thank you.
I'm Chairman James, and I will also continue from output. So, what is output in the computer? Output is the final result a computer gives after it processes your input. This could be text on a screen, sound from a speaker, or a printed document. So the computer receives input, then it processes it. Then it sends the results to an output device. Yeah. So this is how a computer talks back to us. Yeah, for sure. And we also look at how output works. The CPU process your commands. Then it sends the results to output device. Then this device converts computer data into something we can understand like image, sound, or document. And we also look at output device and their functions. So monitor, it displays text, images, videos, and printer also produce physical copies, example, papers. Yeah. And speaker also plays sound and music. LEDs show status or alert like power light. And projectors also display content to big audiences. Network interface. It also sends output to other systems or users. And we also look at types of output. Yeah, types of output. So we have visual output. Yeah. An example is image on a monitor. Yeah. And also have audio output. That one example is music from a speaker. And we also have hard copy output. That one example is printed paper. And last, we have status output. Yeah, this one too. Example would be LED light. Showing battery level. So I'm done with my part.
Okay, my name is Otno Jusi, and I'll be taking the outputs unit in agriculture. It receives data from the CPU or memory. It also converts data from binary to human readable form. It also sends the data to an output device. And next slide. And I'll be continuing with why output is important. Why is output important? Yeah, this is because it completes the input process output, which is the IPO cycle. And also without outputs, we wouldn't know if the computer did editing or not. Output helps us see, hear, print, or share results. Then the next slide, what I'll be talking about next is input-output system in agriculture. What input-output system is managed by? The input-output system is managed by controllers, which are special hardware to manage data exchange. Also, it's managed by device drivers. Device drivers are software to control the input and output hardware. Also, the input and output system in agriculture is managed by the input and output bus, which carries data between CPU, memory, and input and output devices. I'll continue with the input-output techniques. I'll be talking about the methods and the descriptions. The first one is pooling. With the pooling, the CPU keeps checking if the CPU keeps checking of the output and input devices. And also, the second one will be interrupts. With the interrupts, the device alerts the CPU when it is ready, which is when the input has been received. And also, another method is the direct memory access, which is also known as the DME. With this, the data moves directly between memory and input-output devices, freeing the CPU. Yeah, I'm done.
The memory map input output versus the isolated input output. So the memory mapped devices share address space with memory, and in the isolated input output, they separate address space and instructions for input outputs. And then we have the advantages and disadvantages. In the input output performance, the speed matches between the CPU and the input output devices. The second one, the use of the buffers, the caches, and then the queues. And then we have the latency and throughout inputs, the input output system. We have error handling in input outputs. That is the parity checks, the CRC, and the timeouts. And the role of device drivers is necessary for error recovery. And then we have the redundancy in critical systems. And the real-life application and examples of these are, we have the embedded system sensors, that's like the sound you get from your system or your PC. And we have the user interface devices, how input and output device drive experience. And then we have the input output in OS, that is the file system and the network communication. Thank you.